A soccer player is running across the field towards the opponent's net. She kicks the ball towards the net with a speed of 14.7 meters per second and at an angle of 28 degrees above the ground. A, how long was the ball in the air? And B, what is the horizontal distance that the ball travels before hitting the ground? Okay, so I'm going to divide this problem into steps. So my first step here is that I'm going to draw a picture of what's happening. So I'll call this step 1, draw a picture. Now when I draw my picture, I'm always going to draw my x and y axis. Okay, so I'm going to make it so my y axis always points up, my x axis always points to the right. And this tells me that the positive x direction is to the right and the positive y direction is upwards. Okay, then I'm going to draw the initial velocity vector. So I'm going to assume that the ball starts off right at the bottom, so I'm going to start it right at the origin here. And from that, the ball is being kicked at an angle, so it's going to go at some angle like this. Okay, so this is my initial velocity vector, v initial, and it equals 14.7 meters per second, and it's at an angle of 28 degrees above the ground. Okay, so the next thing I'm going to do is draw the path of this ball. Okay, so it starts off down at the origin, and then what happens to it? It gets kicked up, it goes flying through the air, and then it goes up, and then it starts to come back down, and it lands on the ground somewhere, let's say right here. Okay, part B is asking what is the horizontal distance that the ball travels. So it's asking for this value right here. So what is this value? So I can put in any letter for that. I'm just going to call it D for the distance, and I could call it anything. I could call it X or whatever I want. Okay, so I've put in all the numbers that I know on this graph. It starts off at the ground, so the Y value right here is 0, the X value is 0, and at the end the X and the Y value are, the X value is D and the Y value is 0. So I'm just going to write out my initial, my final position. So my initial position and my final position. Okay, so my initial is over here, and that's at 0, 0. And my final position down here, which is at D, comma 0. Okay, the X value here is D, and the Y value is 0. Okay, so the second step now is going to be to make a table. Okay, so my table is my X and Y table. So I'm going to label it as X, Y, and along the left side I'm going to put in the variables from the kinematic equation. So I have S initial for the initial position, S final for the final position, V initial for the initial velocity, V final for the final velocity, A for acceleration, and delta T for the amount of time that went by. Okay, so I'm going to make this into a table, and then I'm going to fill it out. So I'm going to fill out everything that I know here. So my initial position was 0, 0. So the X coordinate is 0 and the Y coordinate is 0. My final position is D, comma 0. So my X coordinate is D and my Y coordinate is 0. My initial velocity, so I'm looking for the X and the Y coordinate of this velocity vector. Now the velocity vector is on an angle, so what I need to do is decompose this vector to find the X, so that would be V initial X, so that's the X component, and the Y component. Okay, the X component is always horizontal and the Y component is always vertical. So when I'm looking for the X component, that side is the adjacent side to the 28 degrees. So since it's adjacent, I'm going to use SOHCAHTOA, ka, because of adjacent is there. So I'm going to use cos. So it's going to be 14.7, which is the hypotenuse, cos of the angle, which is 28 degrees. When I look for the Y component, that side is opposite of the 28 degrees. So I'm going to use SO because of that opposite side. So I'm either choosing between cos or sine. So it's going to look exactly the same except with a sine there. 14.7 sine 28 degrees. Before I move on, I should check to see if anything is negative. So my initial velocity vector is moving to the right and upwards. So that's why my vectors are going to the right and up. And since I said that right is positive and up is positive, the x and the y coordinates are both positive. So I don't need to put negatives in front here. Okay, my final velocity. The final velocity is the velocity that the ball will be hitting the ground at. So that velocity, we don't know what it is, so I'm just going to ignore it. We don't know what the value is, so I'm not going to put anything in. Acceleration. So the only force that's acting on this ball is the force of gravity, and that force is pulling the ball downwards, okay? And the acceleration due to gravity is 9.80 meters per second squared, and it's pointing down. So what is the x component of that vector? Well, it's only pointing in the vertical direction, so there is no x component, so that would be 0. And the y component of it is 9.80, but since it's pointing down, and down is negative, we have to put a negative sign in front, so it's negative 9.80 meters per second squared. Okay, and this will always be true for projectile motion problems. The x component of acceleration will always be 0, and the y component will always be negative 9.8. Okay, so we made our table, we filled it out. We're moving on to step 3 now. Okay, so in step 3, what we're going to do is we're going to choose the column in the table that has the most information, and we're going to solve for time. So here's step 3. Choose column and solve for time. Okay, so I'm looking at the x column versus the y column. As you can see in the x column, we have this unknown variable, the d. We don't know what it is. But in the y column, we know the value. It's 0. So we have more information in the y column. So we're going to choose the y column. In other questions, you might know this value over here, the d. You might know the actual number, and you might be looking for a y value instead. And so you would choose the x column. Okay, so I'm choosing the column that is under the y over here because it's the column that has the most information. So I'm going to choose the y direction, and I'm going to write out y direction here because it helps me to stay organized. So this is the y direction. So now I'm trying to solve for time. Okay, time is the one variable that is the same every time in both the x and the y direction because time is not a vector, it's a scalar. It doesn't have a direction. The amount of time it takes something to travel in the x direction is the same as in the y direction. So whatever I get for time, I can put it in both columns. Okay, so I'm going to choose the y direction because it has the most information, and I'm going to solve for time. Okay, so this is what we're looking for first. And even if the question didn't ask me for time, I would still need to do this step. Okay, so I know my initial and final positions. I know my velocity, my initial velocity. I know my acceleration. I'm looking for time. I don't know my final velocity, and I'm not looking for it. So I'm looking for the kinematic equation that does not have final velocity in it. So that would be this equation. S final equals S initial plus V initial delta t plus 1/2 a delta t squared. And now I can just start to sub everything in. So my S final is 0, my S initial is 0, my V initial is 14.7 sine 28, delta t is what I'm looking for, my A is negative 9.8, and then I have delta t squared. Okay, so I'm going to rewrite this, but I'm going to rewrite it in order. So the 1/2 times negative 9.8 delta t squared will come first. So when I type this up, 1/2 times negative 9.8, I get negative 4.9 delta t squared. And now I'm going to type the next piece up on my calculator. So I have 14.7 sine 28. So when I type that up, and now I want to keep extra digits here because this isn't my final answer. So I get 6.90123 delta t, and that's it. right? The zeros are all gone, and so on my left side, I'm just left with 0. So if I think of the quadratic formula now, since this is a quadratic, I have an exponent of 2. I can use the quadratic formula. I just need to know what my a, b, and c are. So this first term would be my a, the second term would be my b, and there is no third term, so there's a 0 there. That's my c. Okay, so I'm going to use these numbers in the quadratic formula. All right, so let's put in the quadratic formula. I'm solving for the variable delta t, so that's what I'm using in my quadratic formula. Delta t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I plug in all those numbers, so negative, my b value is 6.90123 plus or minus the square root. Now my b is being squared, I'm going to put it in brackets, 6.90123. The brackets don't make a difference unless the b is negative. If it's negative, it needs to be in brackets. Minus 4, my a is negative 4.9, and my c is 0. All over 2 times negative 4.9. Okay, so I'm going to type this on my calculator. I'm going to enter it twice, once with the plus sign and once with the minus sign. So when I enter it with the plus sign, I'm getting 0. And when I enter it with the minus sign here, I get 1.40841. Okay, so since this is the final answer for part A, let's go back. Part A is asking us how long was the ball in the air for? Okay, so there's two numbers I'm getting, 0 and 1.4. So that's telling us that at 0 seconds at the beginning, the ball is at the ground. So the height is 0. And also at 1.40841 seconds, the ball is also on the ground. Okay, so the question's saying how long is the ball in the air for? So the ball's in the air for the 1.40841 seconds. Okay, so that's my answer. So I'm just going to write 1.4. I'll round it to two decimal places. So 1.41 seconds. Okay, so part B. When I move on to part B, I'm going to move to the next step, step 4. And in step 4, what we're going to do now is take the time that we got, so this is the time here, 1.40841, and put it in both columns, 1.40841, because again, the time is the same whether you're talking about the x direction or the y direction. Okay, so now what we're going to do is solve for the unknown variable in the other column. So here we are in that last one was step 3. So now we're in step 4. Solve for unknown in the other column. Okay. So now we're moving on to the x direction. So I'll just scroll up a little bit so we can see everything. So in our x direction now, we have more information. We know the time. So we can solve for the d. Again, we don't know the v final and we're not looking for the v final, so we're going to use the same equation as before, the one that doesn't have v final in it. S final equals S initial plus v initial delta t plus 1/2 a delta t squared. So my S final, I use the letter D here, so I'm going to call it D, equals S initial is 0. Again, I'm just focusing on all the numbers or letters that are in the X column, plus V initial, which is 14.7 cos 28, delta t, and delta t we found was 1.40841, plus the 1/2 times a delta t squared. Now the a over here is 0. So since a is 0, the whole term becomes 0. So it's all gone. So I'm not even going to bother writing it in. Now I just have to type this onto my calculator. And I get 18.28 meters. And that's my final answer. So the distance traveled, the horizontal distance that the ball travels, is 18.28 meters. And that's all. All right, I hope this helps, and thank you for watching.